Here's how to solve a fairly simple trig equation. The first thing you need to do is ensure that the equation has the trig function completely on its own. So we can rearrange this equation to give us sine theta is equal to 5/7. Now this equation has a set of values that theta can be between 0 and 360 degrees, and we're going to look for any solutions that are in that range. Now the first solution is really quite easy to find. You can use your calculator and just use the inverse sine button. Inverse sine of 5/7 will give you one solution of 45.6 degrees. However, this is only one solution and there could be more. Now to find others, our calculator won't be much help. But what we can do is we can consider what this one solution looks like on a set of axes. So 45.6 degrees will be here. Now because our equation is sine theta is equal to 5/7, that's a positive outcome. So any solution will be in the quadrants where sine is positive. Now in this case it's in quadrants 1 and quadrants 2. So that means there is another solution that's going to have the same acute angle with the x-axis, but in the second quadrant. Now to summarise this, we've got one solution of 45.6 degrees, and there will be one more solution which to three significant figures will be 134 degrees. So these are two solutions which are in the range 0 to 360 degrees. Right, I'm going to leave this up, and now it's your turn. So if you try, I'm going to set you two questions. All of these are for values of theta between 0 and 360 degrees. The first trig equation I want you to have a go at solving is tan theta is equal to root 3. And the second equation I want you to have a go at is 3 cos theta is equal to -2. So if you pause the video now, have a go at these and resume the video when you're ready to check your solutions. Here are the solutions. You can check to see what's going on. In particular for the second problem, the answer 132 degrees prompted this drawing, and you had to show that the acute angle here was 48 degrees. Right, moving on to a more tricky trig equation. Now clearly we're going to have some trouble because we've got two different trig functions involved. Now the challenge here is to change this so that there's only one trig function involved. Also, it's worth pointing out that our range of values clearly show us that we're dealing in radians, that theta's got to be between 0 and 2 pi. Now for this we've got a sine and a cos involved, and with a little bit of manipulation, if we divide both sides by cos, we can basically use the idea that sine theta over cos theta is equal to tan theta. Let's try that in a different colour. So we can show that this equation is the same as 1 is equal to minus root 3 tan theta. So in other words, tan theta is equal to minus 1 over root 3. Now from here it's going to be the same setup. We can get one solution by using tan inverse 1 over root 3. That will give us a solution of minus pi over 6. And these we can now draw on the coordinate axis. So minus pi over 6 will be down here in the fourth quadrant. Now our values of theta have to be between 0 and 2 pi. So actually minus pi over 6 isn't a valid solution. But what it does do is show us where the solution will lie on the axis in the fourth quadrant. But there's another quadrant that produces tan values which are negative, which is in the second quadrant. So we'll have other solutions here. Once we've done this, it's just a case of reading off what the solutions are going to be. So our solution in the second quadrant will be 5/6 pi, and our solution in the fourth quadrant will be 11/6 pi. And there are no more solutions within our range of values of theta. If, for instance, the ranges of theta were between 0 and 4 pi, then we'd get two more solutions by going round the coordinate axes again. Okay, so now that you've seen that, it's your turn. So I'm going to give you two equations, and both of these will be in radians. So the first one is that sine theta is equal to 1 over root 2, and this can be valid for any values of theta between minus 2 pi and pi. That's question one. Question two for you to have a look at, which will take a little bit of manipulation first, is that 2 brackets 1 plus tan theta is equal to 1 minus 5 tan theta, and this is valid for values of theta between minus pi and 2 pi. So have a go at these two questions. If you would like to pause the video now and then resume when you're ready to check your answers. Okay, here are two solutions. First equation, fairly standard, except within this interval there are 4 solutions altogether. Second equation, a bit of expanding and collecting terms together. You can show that tan theta is minus 1/7, and then the solutions come from there.